This video is on the features of functions. So there's first some vocabulary that you're going to want to get down. And so you may want to pause this and copy down the vocabulary and then come back and I will explain each one. And as we go through the lesson, you hopefully will get any other additional questions that you have answered. So the first thing I'm going to talk about is end behavior. End behavior is where the graph goes at the start or at the end of the graph. For instance, these two arrows indicate the beginning and the end, for better term, of what the graph is doing. So end behavior will describe what's happening as this x is getting smaller, what's happening to the y, as the x is getting larger, what's happening to the y. And I'll show you the notation and specifics on that in just a minute. The intercepts you already have some experience with. That's where the graph crosses either the x or the y axis, depending on which intercept you're looking for. A maximum or a minimum is where the graph has the greatest or least y value. For example, take a look. This is the maximum here at this little hump because it doesn't get any larger than that before it starts back down. But I have a couple of little curves here that represent what we call local maximums or local minimums. This is a local minimum. It's not really the smallest that the entire graph has because the graph is going to go all the way down here to infinity. But in this region right here, this is the lowest value of y here, so we call it a local minimum. And the same thing here. This is a local maximum, this bump. It's not the highest value of y, that's over here. But this local maximum gives me a little bump, okay? Now, whether a graph is increasing or decreasing depends on the values of y. So I would say that here, the values of y are increasing, but look, oh, here they go downhill, now they're decreasing. Oh, now they're going back up, increasing, now they're going down and decreasing. So when we talk about whether a graph is increasing or decreasing, we mean the values of y. Odd or even, we're going to spend a little bit more time on that because it's a little more complicated. It's whether the function gives out the same y value when you plug in an x and a negative x. Meaning, if I plug in a 3, do I get the same value out as I get if I plug in a negative 3? If I do, then it's even. If I get the opposite value out, then it's odd. And if I don't get either of those things, then it's neither one. But we'll spend more time on that. Whether a graph is positive or negative is very much like increasing or decreasing. It depends on the y value. So if I take a look, here's where down here where the y is below 0, it's negative, negative, negative. Whoop, it switches positive, 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 positive. So if the y value is negative, my graph is negative. If my y value is positive, my graph is positive in that spot. Okay? Whoop. Okay, now we're going to just review quickly and make sure everybody's comfortable with how to find an intercept. Okay? So here's my function, f of x equals 6x plus 3. Now, to find the y-intercept, I plug in 0 for x. You're always going to plug in a 0 for the opposite variable. So if I plug in a 0 for x, I get 6 plus, times 0 plus 3, 0 plus 3, and 3 is my y-intercept. If I want to find the x-intercept, I plug in 0 for y. 0 equals 6x plus 3, I subtracted 3. Negative 3 equals 6x, I divided by 6. Negative 3 over 6, which simplifies to negative 1/2, is my x-intercept. This is where it crosses the x-axis. This is where it crosses the y-axis. So these are valuable features on a graph to know. I'm not going to spend more time on that because we used to do that a whole lot in Algebra 1. So if you still have questions when you come to class, then I'll address those individually. So please jot those down. Now let's talk a little more detail about end behavior. There's a specific notation that you have to use for end behavior. So first let's talk about what's happening. In this graph right here that I've drawn, as x gets smaller, see x getting down to the farther and farther negative, I see that y is getting smaller, but it's only getting down closer and closer to 0. So the way I would write that is x arrow negative infinity. This says as x is getting smaller, y is approaching 0. Okay, so this arrow means approach. Negative infinity means getting smaller, and you know what 0 means. So this notation says as x is approaching negative infinity, y is approaching 0. Okay? Now let's look at the other side. As x gets bigger, I could keep adding more and more terms in for x. Look what's happening to y. Y is also getting bigger. So that says as x approaches infinity, y approaches infinity. So these two terms here in red is how you're going to describe end behavior. You're going to have what's happening on one end and what's happening on the other end. That's why I have two different explanations. Okay? So let's take a look at what that looks like. All right? Take just a minute, pause this, and describe the end behavior on these two graphs. I've started this one here to remind you what the notation looks like. I want you to use that same notation in this one as well. Okay, hopefully you saw that. As x approaches negative infinity, that means this direction, y is approaching infinity. It's getting bigger. And as x approaches positive infinity, y is also approaching infinity. Okay, so these two will be the same. This one is x is negative infinity, y is positive infinity. Okay, this one here, I look as x, when I go in this direction, as x is getting toward negative infinity, look where y is. Y is also approaching negative infinity. As x is approaching infinity on this side, y is also approaching infinity. So in this case, they're both doing the same thing. Okay? Okay, and our last concept we're going to talk about is odd or even. And this one is a little confusing because before when we looked at graphs, we were identifying the degree of the graph. The degree of the graph is sometimes talked about as being odd or even. The degree refers to the highest exponent that's in the graph, and it tells us things about whether the graph is going up, whether the graph is switching, whether the graph is a straight line. The highest degree coefficient, the highest degree exponent in the equation tells us what the degree of the equation is. But when we talk about odd or even, it's slightly different. So we call an equation or a function even if when I plug in an x, whatever value I want for x, I get the same number out as when I plug in a negative x. Okay? It's an odd function if when I plug in an x, I get the negative number when I plug in a negative x. So we need to look at what this looks like so you can have a better understanding. So here's a function, f of x equals 3x plus 4. So I decide on the number 2 and negative 2 because this involves me plugging in a number and its opposite, a number and its opposite. Okay? So when I plug in a 2, I get 3 times 2 is 6 plus 10 plus 4 equals 10. So this is what I get when I plug in a positive 2. This is what I get when I plug in a negative 2. Well, they're not the same, so it's not even, but they're also not the same number with the opposite sign, so it's not odd. So this function here is neither odd nor even. Okay? I need to do more. I can tell, even though I'm only looking at you through this camera lens, I can tell. We want to look at this again. So I decided to try another one. Negative 3x squared plus 4. Okay? This time I'm just going to pick 1 and negative 1. It doesn't matter what x I choose to put in. I'm going to put in something that looks easy to solve. So here's me plugging in the 1. 1 squared is 1. 1 times negative 3 is negative 3. Plus 4. Negative 3 plus 4 is 1. Okay, so when I plugged in the positive number, I got a 1. Now, when I plug in the negative number, negative 1 squared turns into 1. 1 times negative 3 is negative 3. Negative 3 plus 4 is... Oh, I get the exact same answer. Why did I get the same answer? Because that negative that I plugged in here got squared. Okay? So, if they get the same answer, that means this is an even function. All right? Now, you have several of these on your worksheet as well as an additional explanation and sample. So I have a lot of confidence that you can look at those and figure those out. But here's a hint that you might want to put in your notes. If all the exponents in a function are even, then that function is even. Okay? Now here there is no exponent. This represents x to the 0 power. So I have an x to the 2nd power, that's even, and an x to the 0 power, that's even. Both of these are even, therefore the function is even. It doesn't matter what this is an odd number, that has nothing to do with it. It has everything to do with the exponents that go with it. Okay? By the same token, if all the exponents were odd, then I'm going to have an odd function. That means if I had x to the 3rd power, and x to the 1st power, and x to the 5th power, and only those, I would have an odd function. And if there's a mix, x to the 3rd plus x to the 2nd plus x, see how those are mixed, odd and even? Then it's going to be neither one. But I want you to use those ones in your notes, practice with those, and look things over, And make sure that you write down a key question that you can share in class tomorrow. We're going to be going over those.